Welcome to our comprehensive guide on shell scripting interview questions for Bash and Linux. In this series, we'll cover the essential concepts that every system administrator and DevOps engineer needs to master. Shell scripting is a powerful tool for automation, system administration, and DevOps practices. Whether you're preparing for technical interviews or looking to strengthen your Linux skills, this tutorial will provide you with the foundational knowledge you need to succeed. Shell scripting is the process of writing a text file that contains a series of commands to be executed by the shell interpreter. A shell script automates tasks and system operations that would otherwise require manual input. The basic structure starts with a shebang line, which tells the system which interpreter to use. For example, #!bin/bash indicates we want to use the bash shell. Following this, we can write commands like echo to display output, ls to list files, and pwd to show the current directory. This automation saves time and reduces human error in repetitive tasks. Before diving into scripting, let's review essential shell commands that form the building blocks of any script. File operations include ls for listing files, cd for changing directories, pwd for displaying the current path, mkdir for creating directories, cp for copying files, and mv for moving or renaming files. These commands are fundamental to file system navigation and manipulation. Quick examples include ls-law to show detailed file listings, cd/home/user to navigate to a user directory, mkdir backup to create a backup folder, and cpfile.txt backup/ to copy a file to the backup directory. Conditional statements allow scripts to make decisions based on different conditions. The if-else syntax in shell scripting uses square brackets to evaluate conditions. The basic structure is if followed by a condition in square brackets, then the statement to execute, optionally else with an alternative statement, and finally phi to close the condition. Common comparison operators include -ek for equal to, -ni for not equal, -lt for less than, -gt for greater than, -la for less than or equal to, and -g for greater than or equal to. These operators work with numeric values and enable scripts to respond dynamically to different scenarios. Loops allow scripts to repeat operations efficiently. The for loop iterates through a list of values. For example, for I in 1, 2, 3, 4, 5, do echo number $i, done will print each number. The while loop continues executing as long as a condition remains true. A typical while loop starts with a counter variable. Then while the counter is less than or equal to a value, execute commands, increment the counter, and done to end the loop. These loop structures are essential for processing multiple files, iterating through data sets, or repeating operations until a specific condition is met. Functions in shell scripting help organize code and promote reusability. A function is defined using the function name followed by parentheses and curly braces containing the commands. Functions can accept parameters, which are accessed using $1, $2, and so on for the first, second, and subsequent arguments. For example, a greet function that takes a parameter would use echo hello $1 to display a greeting with the provided name. Functions can also return values using the return statement. This modular approach makes scripts more maintainable and reduces code duplication. Proper error handling is crucial for reliable shell scripts. Every command in Linux returns an exit status, where 0 indicates success and non-zero values indicate errors. You can check the exit status of the last command using $?. A common pattern is to run a command, then check if $? is not equal to 0, and if so, display an error message and exit with status 1. The trap command provides cleanup functionality, allowing scripts to perform specific actions when they exit or receive signals. This ensures temporary files are removed and resources are properly released even when scripts terminate unexpectedly. File test operators are essential for checking file properties and existence before performing operations. Common file tests include -f to check if a path is a regular file, -d to verify if it's a directory, -e to test if a file exists, -r to check if it's readable, -w to verify if it's writable, and -x to test if it's executable. Example usage includes if -f file.txt to check if a file exists before processing it, or if -d/home to verify a directory exists before changing to it. These operators prevent errors and make scripts more robust by validating conditions before executing operations. Text processing and pipes are fundamental for data manipulation in shell scripts. Pipes, represented by the vertical bar symbol, connect commands by passing the output of one command as input to another. For example, catfile.txt pipe grep pattern searches for patterns in a file. Redirection operators include greater than to redirect output to a file, and to greater than &1 to redirect both standard output and error. Essential text processing tools include grep for searching patterns, sed for stream editing, awk for advanced text processing, cut for extracting columns, sort for organizing lines, and WC for counting words, lines, and characters. These tools work together to create powerful data processing pipelines. File permissions control access to files and directories in Linux systems. The chmod command changes these permissions using either numeric or symbolic modes. In numeric mode, permissions are represented by 3 digits. 755 means read, write, execute for owner, read and execute for group, and read and execute for others. 644 gives read-write for owner and read-only for group and others. 700 provides full access only to the owner. Symbolic mode uses letters, U for user, G for group, O for others, and a for all. Examples include chmod U+X to add execute permission for the user, chmod G-W to remove write permission from the group, and chmod O=R to set only read permission for others. Understanding permissions is crucial for system security and proper file access control.
If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.